Okay, so now we have our three fundamental relationships, and the last piece is to try and work out how we're going to use those relationships to solve problems in one dimension. And what we really end up needing is a governing equation. And we have all of the pieces that we need. So what were those again? First one was equilibrium. And that was the area times the change in stress with respect to x, plus the force per unit length. It's going to be equal to 0. We had kinematics, and that said that the strain as a function of x is going to just be equal to the derivative of the displacement with respect to x. And the last thing that we talked about was our constitutive relation. And that said that stress is linearly related to strain through our elastic modulus. And really all we need to solve 1D problems are in those three relationships. So that's all you need to solve 1D elasticity problems. That's pretty cool, so I'll put an exclamation point at the end. But we can get it into a somewhat simpler form that's going to help us. And that's what's going to be our governing equation. And what we're going to do is we're going to combine all three of these expressions so that we have some relationship between external displacements and external forces. And the fastest way to do that is we're going to start with stress, and that's going to be equal to the elastic modulus times the strain. And what that implies that if I take the derivative of the stress with respect to x, that's going to be equal to the elastic modulus times the derivative of the strain with respect to x. Now I know that the strain is equal to the derivative of the displacement with respect to x, and that means that the derivative of the strain with respect to x should be equal to the second derivative of the displacement with respect to x. So all I've done here is I've taken two derivatives. But now you might be able to see where I'm going with this. You can combine these two pieces together. So now we have, I'll write that here, we're going to combine. So we have the change in stress with respect to x is equal to E, the elastic modulus, times the change in strain with respect to x, which we have here. That's going to end up being the second derivative of the displacement, U, with respect to x. And if we know what the derivative of stress with respect to x, we can plug this into the equilibrium equation. And if we do that, we're going to get here A, right? We have the area out front. We have E, elastic modulus. We're going to have the second derivative of the displacement with respect to x. I think we should have some squares here. Excuse me. Now we're going to add to that B of x. We're still up here now, and that's got to equal to 0. And there you have it. So this guy here is the governing equation for all 1D mechanics. And we can solve all sorts of problems in 1D with this equation. So that's a really important one. I'll put some majesty around that so that we remember it. And the last question I have for you, so this is a differential equation, right? It's second order. The question is, if I have a governing equation and I have a situation, I have a rod, it has some loads on it, can I solve the problem? What else do we need to solve problems? If it's a differential equation, the last piece we need is to talk about boundary conditions.